All right. Hey, everyone. Welcome to the Veritas booth. Show of hands, how many people caught the keynote this morning? All right. For those of you who did, and even if you're going to catch the highlights later, you all are clearly able to see that generative AI is having a moment. And if you think about the last 12 months, this is unlike any platform shift that we've seen. A lot of applications, everything from language modeling to image synthesis. I remember when the stable diffusion phenomena started and people started to play around with text to image synthesis. And I also had some fun creating some avatars. And as we think about what generative AI truly is and what it enables, generative AI is a type of AI that creates net new content, whether that's code, whether that's images, whether that's text, as you can see with ChatGPT. And similar to other types of AI, it is powered by machine learning models. But in this case, a lot of the generative AI applications that we're seeing are powered by really large models that are typically called foundational models. For instance, ChatGPT is powered by GPT, previously GPT-3, now GPT-4. Meta has come out with Llama. There's many other open source examples as well. But now, as we think about what's actually happening when you talk about AI, there's two fundamental steps. The first is called training, and the second is called inference. With training, you're essentially teaching a model to make predictions based on a set of data that it has been able to see during that period. And then it continues to get better and better at making predictions, and you can use that feedback to help it make better and better and more accurate recommendations. And then inference is when you actually deploy that model in production and you're able to see and have interactions with it in real time. For instance, with ChatGPT, if you're going and having a conversation, that's an inference. If you're using DALL-E for image generation, that's an inference. So that is when your model has already been deployed and you're interacting with it in real time. And then you're able to then take feedback from it and also use it to further refine your model. Now let's talk about what ChatGPT has actually unlocked and what generative AI is doing today. ChatGPT was the fastest growing application in the history of any application created. It took 2 months to get to 100 million users, far faster than TikTok, Snapchat, and Instagram. And what that means is there's just a lot of exploding demand for generative AI. However, there's a gap when you talk about consumer-oriented generative AI and true enterprise-grade generative AI. And when we think about that gap, it's really important to first think about what trajectory this whole technology is on. And so, as you can see in the past few years alone, we've seen a 10x scaling year over year. For instance, GPT-3 had about 170 billion parameters, and GPT-4 is rumored to have 1.7 trillion. So if you think about as you start to scale data and compute, one of the very interesting things that has happened in the last few years is while keeping the model architecture largely the same, the transformer architecture came out way back when Google released that paper, attention is all you need. It's just the data and compute that's increasing. The underlying technology isn't really changing that much, and that alone is unlocking so much of a scaling in terms of just performance, and there's no reason to believe that this is not going to continue for the next few years at the very least. However, there's clearly a gap that you might be familiar with as well in terms of the desire to use AI and the actual enterprise-grade adoption of it. For instance, 80% of CIOs planned to implement AI by 2023, but actually only 30% have been able to do so. So you're all familiar with the promise of AI. There was the prediction that it would add up to $16 trillion by 2030 to the economy, but as is clearly evident, there are implementation hurdles, real-world hurdles that you need to grapple with. And so as you're navigating the landscape of generative AI, you might have come across a series of interconnected roadblocks, everything from skill shortage and security concerns. There was a recent report that found that 94% of business and IT decision makers are finding it hard to move the needle in AI. There's also ethical use and privacy concerns. You're ceding control of a lot of your data to essentially a machine learning model. And so it's really important to understand that there's an ethical framework in place and your data privacy is being maintained. And then there's also risks around governance and compliance. You don't want to run into regulatory fines when you're dealing with customer data. And perhaps the most important of all, in order to even really begin to move the needle on AI, it is really important to have a clear vision and a clear strategy. A lot of people are looking at the hype and thinking about, oh, how can I take advantage of this? And I think it takes a crawl, walk, run approach at times to really get familiar with this technology and dabble and actually start to see real results. And so the stakes are high. Being unprepared can lead to missed opportunities, costly failures, regulatory fines, and in the case of data leakage, severe erosion of customer trust. But early adopters will experience outsized returns, as those who have come across the crossing the chasm analogy. Anytime you move from the early adopter section to the early majority is when you start to see an inflection point in terms of your just overall success of the technology in terms of its adoption curve. And McKinsey did a recent study where they found that those who are the early adopters of AI are already starting to see real results. Right now, it's a lot of productivity gains and cost reductions. But in the future, you will also start to see people using these technologies to create net new products, enter net new markets, and then you'll start to see that revenue side of the equation also start to take off as a result of generative AI, boosting overall profitability. And so, as we mentioned, incorporating AI definitely yields rewarding outcomes, from competitive advantage and differentiating yourself from the pack to proactive cybersecurity, where bad actors might be using AI to come up with new ways of attacking your data, but you can also use proactive cybersecurity and incorporate AI into your cybersecurity posture to be able to circumvent bad actors and to be able to predict an attack versus reacting to it. And additionally, the enhanced customer experience that we've come to experience with all of these chatbots, that is going to potentially become the way you interact with your software moving forward, where you have a co-pilot-like experience and you're talking in natural language to your software. And then the improved decision making. AI can analyze tons and tons of data and provide you recommendations in real time, which can help human decision making and act as a productivity assistant and just a co-pilot by your side. And then AI will potentially in the future start to even enable game-changing innovation that is going to help enterprises like yourselves enter net new markets and create net new products. Now, one of the questions that we get really frequently is, okay, there's all this hype around these large language models, but what does that mean for me? What does that mean for my business? And how do I actually take advantage of it? And so ESG, the Enterprise Strategy Group, did a survey where they spoke to 670 respondents, technical and business leaders, and they asked them, how is your organization planning to take advantage of LLMs? And you could answer with more than one option, because people could have more than one use case. And so, as you can see here, the most popular response was, we will utilize an open source LLM and develop a generative AI solution in-house. So essentially, you're taking something like a Llama 2 or a Falcon, and then you're being able to deploy that in your specific use case. The second most popular was we will work with a third-party provider. So there you're talking about things like ChatGPT Enterprise or a hosted cloud solution. And then the third one is we will work with a third-party provider that offers access to an open source LLM and allows us flexibility to customize. Here, you're starting to bring in some GPUs, and you're starting to play more of an active role in perhaps even looking at fine-tuning. But what is very notable is that only 9% said that they will develop a net new LLM entirely in-house. And the reason behind that, it is extremely computationally intensive, energy intensive, and resource intensive to be able to create a net new large language model in-house. And often it only makes business sense to do so when you plan to create a model that you plan to then sell to other enterprises. So what the likes of the hyperscalers have been doing. And for most organizations and in most industries, the first three are going to be the way to go. And one of the ways that we have actually seen that play out in terms of actual deployment is, when you think about the sweet spot for most organizations, there's really two key ways in which organizations are trying to take advantage of these technologies. One is you're using a pre-trained model, which was, like we said, you're looking at an open source, and then you're being able to deploy it for your specific use case. So that is the example, for instance, you're using ChatGPT, but for your specific use cases, or Falcon for your specific use cases. But the one that is actually really interesting, and this is where you'll start to see a lot more announcements from all over, is model augmentation. And this is the concept of you're essentially providing the large language model the capability to talk to your specific enterprise data. And so you are powering it with not just the insights that it was trained on, and which perhaps could be the corpus of the internet as a foundational model, but now it can in real time access your enterprise data. So it has been augmented with the knowledge that lies in your enterprise. And that is a really interesting use case where you don't need to do a ton of computationally intensive tasks, and you only require developers. But then once you start to go further down the more resource intensive task, that's where you require machine learning engineers and a lot of resources, both from a time and money and energy perspective. And some organizations might look to fine-tuning if they are in very specific domains. Let's call it healthcare, pharmaceutical, financial services. But even then, model augmentation will get you almost 90% of the way there. And then this last one, like I said, is you're going to have your large, very, very large technology companies or telcos even start to think about this. And it only makes sense when they plan to open that model up for others to utilize as well and have a much larger framework in place. And so your data greatly improves the efficiency and the value of generative AI. Yes, scaling compute and adding more horsepower is going to help. But as with any technology, garbage in, garbage out, right? And similarly for generative AI, the quality of your data is really going to influence the quality of the outputs that you get. And so large language models are much like an encyclopedia. They're generalists. They're trained on the corpus of the internet. They're foundational models, and they can be used for general purpose tasks and breadth of use cases, but they're costly and energy intensive. And at times, if you're asking them really specific questions, you can get hallucinations or incorrect responses, albeit really confidently. That's one of the things with these large language models is they won't necessarily tell you when they're incorrect, but they'll give you a very confident response. But when you start to go down the path of domain-specific and enterprise-specific data, you can potentially train more lightweight models that are able to perform really specific tasks really well. And you will start to see better performance than these foundation models for perhaps a fraction of the cost. And so as you start to have high-quality data, that's where you start to have really good value generated from these large language models. And so if there's one thing that I will leave you with from this talk is your AI strategy is as good as your data management strategy. And as you start to think about some of the risks around large language models and generative AI, a simple Google search will give you about hundreds of attacks that will come up just in this space. And the three that are really notable are prompt injection, data poisoning, and data leakage. Without going into too much depth here, prompt injection is essentially when someone tampers with your conversation with a large language model and is able to then influence the output that you generate. Data poisoning is during the training process while your training data gets corrupted or polluted. And then data leakage is when you don't have an enterprise-grade solution and you're talking to a public large language model and you're feeding it your enterprise data. That's going to be used to train the larger open source model, which is then essentially now aware of the enterprise data that you just fed it. And so there's real concerns which lead us to the very important call out here that in order to be successful in AI, you need a very strong cyber resilient infrastructure. You need to be able to think about your cyber resiliency from a 360-degree angle, and that's where the Veritas 360 defense posture comes in.